So in this part of the video, we will talk about parametrics more in depth in terms of calculus. So shall we begin? So first, let's C be a parametric curve described by parametric equations x equals ft, y equals gt. If the function f and g are differentiable, and y is also a differentiable function of x, then we will have three derivatives: dy dx, dy dt, and dx dt. And these three derivatives are related by this chain rule, which is dy dt equals dy dx times dx dt. So using this we can obtain the formula to compute dy dx from dx dt and dy dt. So we will have dy dx will just be equal to dy dt over dx dt if dx dt is not equal to 0. So recalling from calculus, the value of dy dx gives the slope of a tangent to the curve at any given point. So this can sometimes help us to draw the graph of the curve. And the curve has a horizontal tangent when dy dx equals 0. And it has a vertical tangent when dy dx equals infinity. So the second derivative, d squared y over dx squared, can also be obtained from dy dx and dx dt. So in this case we will have d over dx dy dx, which is also d over dt dy dx over dx dt. And again, if dx dt is not equal to 0. Okay. So if you want to take note, you can pause the video for a second. And shall we continue? Okay. So let's go through some examples. So first, say we have parametric equations x equals t squared minus 2t, y equals t cubed minus 3t. So A, find an equation of the tangent to the curve when t equals -2. And B, find the point on the curve where the tangent is horizontal. And C, does the curve have a vertical tangent? And D, we use the second derivative to determine where the graph is concave up and concave down. So since these four questions all involves with the tangent, so first, obviously we want to first find what dy dx is. So in this case, dx dt is, let me use a pencil. In case I do something wrong, I can erase it. So dx dt equals 2t minus 2. And dy dt equals 3t minus 3. 3t squared minus 3. So we have dy dx, which is basically this divided by this. We will have 3t squared minus 3 over 2t minus 2 when this is not equal to 0. Yeah? Okay. So after we found the derivative of the parametric equations, let's go through the questions. So for question A, find the equation of tangent to a curve when t equals -2. So first we will plug in -2 to the two equations to find the corresponding point on the curve. So in this case, the point will be 8 and 8 minus 8, no, it's -8 plus 6, which is -2. So this is a corresponding point we found. And we also found the derivative dy dx. So when we plug in t for the dy dx, we'll eventually get dy dx equals 12 minus 3 over -4 minus 2, which substantiate this, you'll get -3 over 2. So the equation of the tangent would be y plus 2, because y is -2 in this case, equals the slope. The slope, -3 over 2, times x minus 8, because x is equal to 8 in this case. Okay, so this is the equation of the tangent to the curve. Okay, so now let's move on to the second question. So the second question wants us to find the point on the parametric curve where the tangent is horizontal. So still we have the dy dx equals this, and we know that if we want to find the horizontal tangent, we need to first let dy dx equal 0. So if 3t squared minus 3 over 2t minus 2 is 0, we know that 2t minus 2, the denominator, should not equal 0. So we will get 3t squared minus 3 equals 0. Let's first figure out the numerator when the numerator is 0. Okay. So we know that t will be positive and -1. So when t is -1, we have the denominator will not be equal to 0, so the tangent will just be 0. So the corresponding point on the curve when t is -1, we have, plug this into here, we have 3 and 2. But what happens when t equals +1? Then we know that the denominator will be 0, and there will not be a well-defined tangent if that's the case. And if the curve describes the motion of the particle, this will be the point where the particle has stooped. And what I mean by that is that there will be a sharp point in that part of the curve. So if we put out the calculator, go to parametric mode, which if you forgot how to go to parametric mode, you first go to mode, go to the 4th line, choose the par option, and then you go back to y equals to graph the parametric equations. So in this case we have x equals t squared minus 2t, and y will be t cubed minus 3t. In the window, we will set it, let's see, from t to, let's see, t minimum is -2, t maximum is 0. And then let's see what will happen to the graph. Let's graph it. Maybe it's not like a well scaled graph, so let's say maximum is 0, maximum is 0. let's reset the window. You can see that there is a sharp point over here. You can't see it clearly. So that is when t equals +1 and denominator is 0. There will be like a sharp point over here, which is not a horizontal tangent. So it's not a well-defined tangent. Okay. So after we found the horizontal tangent, let's go to the next one. So does the curve have a vertical tangent? So still we have the same derivative dy dx. So the curve has a vertical tangent if the denominator is 0, because we know that when denominator is approaching 0, the derivative will approach infinity. So if that's the case, we have 2t minus 2 equals 0, and t will be equal to 1. However, when t equals 1, the numerator is also 0. So when in this case, 3t squared minus 3 is also 0. So the curve will not have a vertical tangent if the numerator and denominator are both 0. So it does not have a vertical tangent. And use the second derivative to determine where the graph is concave up and concave down. So in this case, let's first find the second derivative. I'll write in here. d squared y over dx squared is equal to d over dt 3 over 2 t plus 1 over 2t minus 2, and it equals 3 over 4t minus 4. So we see that when d squared y over dx squared is greater than 0, we have the graph concave down. And if we have d squared y over dx squared smaller than 0, we have the graph concave up. So in this case, t will be equal to, not equal to, but t will be greater than 1 if the graph is concave down, and t will be smaller than 1 if the graph is concaving up. It's concave up. And when t equals 1, just like what we described in the second question, the point on a curve is